The chain hit 240 miles per hour, tore through 18 inches of Australian hardwood, and then, in front of 11,000 people, the engine ate itself from the inside out. $15,000 of billet aluminum and titanium reduced to shrapnel in 4.2 seconds. The saw never cut again. The builder had known it wouldn't. He built it specifically to destroy itself, just not that quickly. His name was Russ Orms, and in 2003, he held a world record no corporation would ever sponsor and no insurance company would ever underwrite. But to understand why a man would spend the cost of a decent truck on a saw that lives less than 10 seconds, you have to go back to a county fair in upstate New York, 1982, where the whole thing started as a joke. And before you can understand that, you need to know what happens when you take a tool designed for logging, for hour after hour of controlled, predictable work, and reverse engineer it into a mechanical suicide vest. Start with the saw itself. A chainsaw, in its factory form, is a study in compromise. Steel, Husqvarna, Echo, they're all building for endurance, fuel efficiency, operator safety. A logging grade saw might run 6,000 RPM and weigh 11 pounds. It's designed to cut all day without grenading. It's boring. It works. A hot saw has no use for any of that. Strip the case off a competitive hot saw, and you won't find a chainsaw engine. You'll find something that was never meant to be bolted to a cutting chain. Sometimes it's a Husqvarna two-stroke opened up to 130 cc. Sometimes it's a built sprint bike engine. Sometimes, and this is where it gets strange, it's a hand-fabricated motor that exists nowhere else on Earth, designed by a man in his garage using CAD software at a CNC mill he built himself. These engines don't idle. They don't warm up. You pull the cord, the chain goes from 0 to terminal velocity in under half a second, and you have maybe 12 seconds before heat, friction, or mechanical failure ends the run. The chain itself is another problem. Factory chain is designed to stay sharp through hundreds of cuts. Hot saw chain is sharpened to a surgical edge and thrown away after a single run. Some builders use carbide-tipped teeth. Others hand file each cutter to a mirror finish the night before competition, alone, in shop light, the way a sniper might hand-load ammunition. The log doesn't stand a chance. When a hot saw hits wood, it doesn't cut. It evacuates. The kerf, the width of the cut, is nearly 2 inches wide, and the sawdust doesn't fall. It explodes outward in a rooster tail that can reach 15 feet. The sound isn't the whine of a chainsaw. It's a shriek, mechanical and furious. The kind of noise that makes people in the crowd step backward without realizing it. County fairs, logging expos, small timber towns in Washington, Montana, Northern California. No governing body, no sponsors, just builders and cutters passing knowledge face to face, engine to engine. By the mid-90s, there were maybe 200 people in the world doing it seriously. And then someone did the math on what these engines were actually doing, and it should have ended right there. A hot saw chain moving at 240 miles per hour is traveling at 352 feet per second. Each drive link on that chain weighs a fraction of an ounce, but at that speed, if a single link separates from the bar, it becomes a projectile with enough kinetic energy to penetrate a car door. The chain is under constant screaming tension. The bar heats up, the oil burns off, the clutch is slipping at forces that would stall a motorcycle, and there are no brakes. In 1998, a saw in British Columbia threw its chain mid-cut. The chain wrapped itself around the operator's forearm in less than 1/10 of a second. It didn't cut him. It crushed the radius and ulna like a steel whip, fractured in 4 places. He finished the cut one-handed. Then he walked off the platform and drove himself to the hospital. He was back competing 6 months later. That's the kind of person this attracts. But it still doesn't explain the money. $50,000. That's the whispered number for what a top-tier hot saw costs to build, test, tune, and campaign for a single season. There are no prizes, there are no endorsements. The best you can hope for is a handshake and your name on a plaque at a sawmill in Oregon that closed in 2004. So why? The answer sits in the same psychological space as land speed racing, rocketry, ultra-distance sailing. It's not about the destination, it's about submission to a singular obsession, the kind that makes you throw out a $6,000 crankshaft because it's 30 grams too heavy. These men, and they are almost universally men, older, rural, with machine shops in their garages and decades of timber work behind them, are chasing a number. Not victory, a number. The elapsed time of a cut measured to the 100th of a second. And every year, that number gets smaller. But the closer you get to zero, the weirder the engineering becomes. And that's where Russ Orms comes back into it. Orms was a millwright from Queensland, 53 years old in 2003. Built his first hot saw in 1991 from a written-off Still 090 and a dirt bike carb. It lasted 3 cuts. He was hooked. By 2000, he wasn't modifying saws anymore. He was fabricating engines from billet, raw aluminum blocks machined to tolerance in his shed. No off-the-shelf parts, no manufacturer support. Just CAD drawings, a lathe, and an understanding of two-stroke thermodynamics that would make a GP motorcycle engineer uncomfortable. His 2003 saw made 48 horsepower at 16,000 RPM. It weighed 19 pounds. For context, a factory Still MS-880, the biggest saw they make, produces 6.4 horsepower. Orms had built something 7 times more powerful, and it was spinning a chain nearly twice as fast as physics said was stable. He test-fired it once. It ran for 9 seconds. He never started it again before the competition. The log was ironbark, 18 inches across, dense enough to sink in salt water, the kind of wood that dulls a factory chain in 2 cuts. Orms set the saw on the log. No warm-up. He looked at the timers, pulled the cord. The engine lit with a sound like tearing sheet metal. For 3 seconds, it was perfect. Then the piston seized, not gradually, instantly. The conrod snapped. The crankshaft, spinning at 16,000 RPM, lost its counterweight and went eccentric. The entire engine tried to rotate inside its own mounts. The chain was still moving, coasting now on inertia, and it finished the cut even as the engine disintegrated behind it. The log hit the ground. The timers stopped. 4.2 seconds. A world record. The saw never ran again. And that specific irrecoverable self-destruction is when you start to understand what this is really about. These men aren't building machines to last. They're building them to exceed, to cross a threshold no production tool is allowed to approach. A hot saw is entropy made visible. It's the opposite of craftsmanship. It's engineered failure, postponed just long enough to do one impossible thing. You tune it until it's on the edge. Then you push it past the edge, and you measure how far it gets before it dies. That's the sport. But it's also what made it dangerous in ways no one anticipated. Not from the chains, or the noise, or the flying splinters. By 2005, the engineering had gotten so extreme that saws were grenading before the cut, flywheels coming apart on startup, fuel systems vapor locking from heat soak, titanium fasteners shearing under load. One saw in Washington launched its carburetor 40 feet into a crowd. No one was hurt. It was luck. The insurance underwriters noticed. And in 2007, something happened in Alberta that no one involved will discuss on the record. But it ended the sport at every sanctioned event in North America for nearly 3 years. The logs were white spruce. The saw was a custom build, engine origin unknown. Witnesses say the chain was moving too fast to see, just a silver blur and the smell of burning bar oil. Halfway through the cut, the bar snapped, not the chain, the bar itself. 36 inches of laminated steel, fractured laterally from heat stress and harmonic vibration. The chain, no longer guided, whipped sideways, still under power. It took out the operator's left hand at the wrist, took 2 teeth from a judge standing 9 feet away, embedded itself in a support beam. The event was over. The lawsuits started 6 weeks later. Within a year, every major logging expo in the US and Canada had dropped hot saw exhibitions. Liability, insurance, the risk wasn't theoretical anymore. That's why the sport almost vanished. Not because people stopped building the saws, they didn't, but because there was nowhere left to run them. The community went underground. Private land, invitation-only events, no video, no press, just a dozen builders in 3 countries, still chasing the number, still grenading motors in silence. It stayed that way until 2011. That's when a retired machinist in New Zealand named Paul Dobrykin published a white paper on 2-stroke thermal runaway that should have been classified as a graduate thesis, except he posted it on a loggers forum for free. Dobrykin had figured out what was killing the engines. It wasn't poor engineering. It wasn't cheap materials. It was time. Specifically, the amount of time between ignition and load. In a normal chainsaw, you start the engine, let it idle, squeeze the throttle, the clutch engages gradually. The engine has time to reach thermal equilibrium. Heat spreads, metal expands evenly. A hot saw goes from 0 to 14,000 RPM in half a second. The piston heats faster than the cylinder. Aluminum expands faster than steel. The tolerances, already machined to a few thousandths of an inch, collapse. The piston swells. The rings bind. Friction spikes. The lubricant film fails. And then you get what Orms got. A cold weld between piston and cylinder wall at 16,000 RPM. Dobrykin's solution was called a preload start. You fire the engine with no chain tension, let it run for exactly 1.4 seconds at partial throttle, then engage the clutch. It gave the engine just enough time to expand uniformly. It worked. Saws that used to last 5 seconds were running 15. Cutters who had never finished a pass were setting regional records. And that's when the sport should have come roaring back. But it didn't. Because by then, something else had changed. The men who had built the sport, the first generation, the ones who learned on home lights and McCullochs in the 80s, were aging out. 60, 70 years old. Hands that couldn't grip a pull start anymore. Ears destroyed by decades of unmuffled 2-strokes. And no one was replacing them. The knowledge wasn't written down. It was demonstrated, passed along in workshops and timber yards. But the timber yards were closing. The workshops were being sold off, and the sons weren't interested. This is a sport with no farm system, no youth league, no pathway. You either grew up in it, surrounded by the smell of bar oil and the sound of saws on Saturday mornings, or you didn't. And if you didn't, the barrier to entry by 2010 was insurmountable. $50,000, a machine shop, a decade of iterative failure. Who's signing up for that? By 2015, there were maybe 40 people left worldwide running true hot saws. Australia had the most, New Zealand 6. The US had maybe a dozen, scattered across Montana, Oregon, Washington. They knew each other by name. They shipped parts to each other. They showed up to the same 3 events every year. And if you were lucky enough to see a run on some rural fairground at dawn, before the crowds, when it's just the builders and the wood and the frost still on the logs, you'd see something that doesn't exist anywhere else in mechanical sport. A man in his 60s, alone, bent over a machine he spent 6 months building, that he knows will last less time than it takes to read this sentence. He pulls the cord. The engine screams. The log explodes into dust. And 10 seconds later, it's over. No trophy, no check. Just the time and whether it was faster than last year. But there's a strange coda to all this. In 2019, a 28-year-old automotive engineer named Eric Schraber, who had never held a chainsaw in his life, saw a hot saw video on YouTube. 12,000 views, grainy footage from an event in Tasmania. He watched it 17 times in a row. 6 months later, he built his first motor. Schraber didn't come from timber. He came from Formula SAE, the college racing league where students build open-wheel cars from scratch. He understood composites, finite element analysis, thermal imaging. He had access to a university machine shop and a simulation software suite that cost more than most hot saws. And he did something no one in the sport had ever done. He modeled the failure. Using thermographic cameras and high-speed data logging, Schraber mapped exactly what happens inside a hot saw engine during a cut. Piston temperature, bearing load, resonance frequency. He found that the engine doesn't just overheat, it oscillates. The crankshaft flexes. The cylinder vibrates at a harmonic that matches the chain speed. The whole system is eating itself from acoustic stress, not just friction. So he built a saw with a counterbalance shaft, dual flywheels, active cooling ports that only open under load. It cost $11,000 and took him 9 months. It ran for 43 seconds before the clutch failed. Not the engine, the clutch. The motor was still perfect. 43 seconds is an eternity. Most saws die in 10. He could have made 6 cuts. He could have idled it. He could have shut it down, let it cool, and started it again. No one in the history of the sport had ever done that. The old-timers didn't know what to do with him. He wasn't one of them. He didn't have sawdust in his blood. But he'd solved a problem they'd accepted as unsolvable. Some of them respected it. Others resented it. One builder from Oregon told him, quietly, after a demonstration, "You've built a hot saw that refuses to die." I'm not sure that's the point. And maybe he's right. Maybe the point is the failure. The fact that you can pour everything you know into a machine and it still betrays you. That you can be perfect for 9 seconds, and on the 10th, physics wins. But Schraber kept building. As of last year, he's running a saw that produces 61 horsepower at 18,400 RPM. It weighs 16 pounds. It has a composite frame, ceramic bearings, and a cooling system borrowed from military drone engines. And it has never, in 14 runs, catastrophically failed. He's also never set a record, because the saws that win, the ones that cut in under 3 seconds, are still the ones that destroy themselves. The ones built by men in their 70s, who learned this in the 1980s and never wrote it down. There's a knowledge in those saws that doesn't translate to CAD. And when those men are gone, 5 years, 10 years, maybe less, that knowledge goes with them. The grainy footage of saws screaming through ironbark in 4.2 seconds. But you won't have the why. The reason a builder chose a 32-to-1 fuel mix instead of 40-to-1. Why he clocked the ignition timing 3 degrees back. Why he wrapped the exhaust port in copper tape. It'll become archaeology. There's a shop in Montana, outside Libby, up a gravel road that doesn't have a name on the map, where a man named Del Frazier still builds hot saws in a barn that hasn't had power since 2003. He uses a hand-crank drill press, a belt sander run off a generator, no CNC, no CAD. He's 76. He's built 19 saws. 16 of them still hold regional records. If you visit, and he doesn't let many people visit, you'll see something that looks like a museum of mechanical obsession. Crankshafts hanging from the rafters, cylinders in wooden crates, each one marked with the date it failed and the cut time it achieved. A wall of chains, sharpened and coiled, that will never be used again. He's training no one. He says there's no one to train. And when he's gone, that barn will be sold. The saws will be scrapped or scattered. And no one will know that the cylinder marked Spokane 02, 5.1 sec, was the first time anyone broke into the 5-second range on a single-cylinder motor, or that it required a piston he carved by hand from billet, because no one made them that size anymore. It'll just be metal. But here's the thing that keeps me awake. Somewhere, maybe in a barn in New Zealand, maybe in a shipping container in Minnesota, there's a saw that no one's ever seen run. A saw that was built in secret, tuned in private, and never brought to competition. The builder is dead now. The saw still exists, and the people who know about it say it was fast, faster than anything that ever ran in public. But no one knows if it would have held together. No one knows what it would have done to the log or to itself. It was built to run once, and it never ran at all. There's no video, no data. Just a saw in a crate, and a claim time written on a piece of masking tape on the cylinder head. 2.9 seconds. If that's real, if the engineering actually supported it, then the world record everyone's chasing is a lie. The fastest cut ever made never happened. It's sitting in a box, unknown, unclaimed, and unfired. And the man who could have proven it took that knowledge to his grave. That's what makes this different from other mechanical sports. In drag racing, in land speed, in aviation, the records are verified, measured, certified. You know what's possible because someone did it and someone else watched. But in hot saws, the fastest runs might have happened in private, on a stump behind a workshop. No timers, no witnesses, just a man and a machine, and a single perfect cut that no one will ever believe happened. So when you ask why someone would spend $50,000 on a saw that lasts 10 seconds, you're asking the wrong question. The question isn't about the money. It's not even about the saw. It's about whether you're the kind of person who can build something perfect, something no one asked for and no one will pay you for, and then destroy it on purpose, just to see if you were right. And if the answer is yes, then the money doesn't matter. The time doesn't matter. The failure doesn't even matter. What matters is that you built it, and it ran, and for a few seconds, you broke physics just enough to make sawdust move faster than it was ever supposed to. The sport is dying. Everyone knows it. The saws are getting rarer. The builders are aging out. The events are smaller, quieter, held in places farther from roads and insurance and liability. But every year, somewhere, someone pulls a cord, an engine screams, a log explodes, and a number gets smaller. And when the last saw finally dies, when the last builder hangs up his files and the last chain goes dull, there will be no museum, just a few thousand feet of grainy video scattered across hard drives and old phones of men who spent their savings building machines that destroyed themselves for no reason anyone outside the sport will ever understand. But there's one detail that still bothers me. That saw in the crate, the one marked 2.9 seconds. 3 people claim to know where it is. All 3 have given different locations, and when you ask them directly, they stop answering messages. So, either they're protecting something, or it never existed at all.